Okay, everybody, we're getting ready to do lesson 3.4, part 2 of your classwork in pre-calculus math today. Let's get into it. 0 points in notebook taking, 140 points of classwork. Incredible. So let's get into it. Here's our bell work today. Teachers, our bell work. Describe the error over here, and then sketch this graph here. Students, give your students, they have to describe this. Graph that. Give them 6 minutes, teachers. Okay, welcome back for your solutions for today's bell work. For this one up here, describe the error, is that both sides of the equation should be divided by 2, both sides divided by 2, before taking the natural log. So you're just starting out taking natural logs here, and that is not going to give you a correct response. Down here, this is the correct response here, x equals natural log 5. And then for number 2, here would be your plot here for that. So you have you drop down 8, and then you shift to the left 2. So this will be your vertex here of your absolute value function there, your graph for the absolute value part of this function. Okay, page 1 of our classwork, solving logarithmic equations. Solve a logarithmic equation. You can write it in exponential form. Natural log x equals 3. Logarithmic form, e to the natural log x equals e cubed. That would be to exponentiate each side here. Then these will cancel. X will equal e cubed. So that would be the exponential form. This procedure is called exponentiating each side of an equation. It is applied after a logarithmic expression has been created. So that's your first part of solving these things. Solve logarithmic equations. Solve each logarithmic equation. Natural log 3x equals 2. So let's exponentiate each side. E to natural log 3 to the x, and then e squared. Then these will cancel. You have 3x equals e squared. Then divide each side by 3. X equals 1/3 e squared. And then you crank this out and you get x equals 2.46. Now, solution for that is 2.46. So let's try here is b log base 3 5x minus 1 equals log base 3x plus 7. So we have a one-to-one property here, so we can divide out our log 3 on each side, and we're left with 5x minus 1 equals x plus 7. And then we just solve for x now. X equals 2. The solution is x equals 2. Check this in the original. Let's go into a problem here. Round the result to 3 decimal places. Natural log 4x equals 2.1, and then down here natural log 2x equals 1.5. So here we raise both sides to e, and then these will cancel here. Your e to the natural log 4x equals e to the 2.1. That'll cancel or drop down, so 4x equals that. Divide through by 4 and you get 2.042. One here, I leave that up to you. Example 7, solving logarithmic equations. Solve 5 plus 2 natural log x equals 4. Subtract 5 from each side. 2 times natural log x equals -1. Divide each side by 2 now. So natural log x equals -1/2. Exponentiate each side. So e to the natural log x equals e to the -1/2. Inverse property. This drops down, x equals e to the -1/2. So e to the -1/2 equals 0.61. Okay, so 0.61 for that one. And then here's the graph for it. And then, so y2 would equal 4 here, then y1 would equal 5 plus 2 times natural log x. And then where this intersects, that would be your solution, and it works out to x equals 0.61. The trick here is to set your viewing window to get this graph. So we'll go over that in class. Okay, we got an issue here. Verify your answer using graphing utility. So we want to solve this graph of this logarithmic equation. Same thing down here. So up here, we add 2 to both sides, divide through by 2, and then we exponentiate each side. E to the natural log 3x equals e to the 19 over 2. This side cancels down, divide through by 3, x equals 1/3 e to the 19 over 2 power, and that comes out to that number there. Moving on, example 8, solving logarithmic equation. Solve 2 times natural log base 5, 3x equals 4. So natural log base 5, 3x equals 2, so we divide through by 2. And then now we're going to jump it up. We're going to exponentiate it here. 5 to natural log base 5, 3x equals 5 squared. So we're going to exponentiate each side, base 5. And then this will cancel. You're left with 3x equals 25. And then we divide through x equals 25 over 3. Then you plug that in back into the original. Or you can check it by graphing. y1 equals 2 log base 5 3x equals 2 times log base 10 3x over log base 10 5. And y2 would equal 4 in this situation here. In the same viewing window. And then the two graphs should intersect at x equals 25 over 3, which is 8.33. And then y equals 4. So this would be your solution here. y2 would be y equals 4. Okay, we have a situation here that we can check it again by graphing. For the first one here, 7 log base 4 times quantity 0.6x equals 12. We're going to divide through by 7, and then we're going to jump it up. We have a base 4 here. Let's jump it up 4 to the 12 over 7 equals 0.6x. Okay, 0.6x here equals 3 over 5. So 0.6x equals 3 over 5x. And then x equals 5 over 3 times 4 times 12 over 7 power, and that comes out 17.945 for this one. Here you can check that. Notebook. Because the domain of a logarithmic function generally does not include all real numbers, you should be sure to check for extraneous solutions of logarithmic equations as shown in the next example. Page 11, your notebook. This goes in your notebook here. And let's go into our next example. Checking for extraneous solutions. Solve natural log x minus 2 plus natural log 2x minus 3 equals 2 times natural log x. So use properties of logarithms. Up here, natural log x minus 2 times 2x minus 3. This is the product property of logs equals natural log x squared. So this goes back up here to x squared. And then multiply binomials. Multiply that. You still have natural log x squared over here. Multiply these together, FOIL them. And then one-to-one property here, you take out your natural log. And then you have 2x squared minus 7x plus 6 equals x squared. And then right in general form, you combine some like terms, and you have this trinomial here. So now we have that trinomial to find zeros, factor this out, come up with that. X minus 6 equals 0, x equals 6. Then x minus 1 equals 0, x equals 1. So now you got to check both these solutions back into the original. We're going to check here x equals 1, we're going to stick 1 in there. X equals 1 is not valid. We put that back in here and we get natural log negative 1. You can't take a natural log of a number. So 1 doesn't work. Negative 1 is not in domain natural logarithmic functions. So the only solution would be 6. So to graph that, we come up with this here. Excuse me. X equals 6 here. So y equals this quantity here, and find the zeros, and then we came up with x equals 6. That is the solution to that. Okay, so we have these two problems here. Round the result to 3 decimal places. So we have a logarithmic equation here. Verify your answer using a graphing utility. So in the first one here, natural log x plus 5 equals natural log x minus 1 minus natural log x minus 1. And then using your logarithmic properties here, you know this produces a quotient here. And then we're going to one-to-one property here. We're going to take out a natural log on both sides, and then we end up with this. X plus 5 equals x minus 1 over x plus 1. And then to solve that, we move our x plus 1 over here, we multiply out, and then we have this equals x minus 1, and then we move this back over here, so x squared plus 5x plus 6, I have to remove this back over here, and then we factor it out, and then we have x equals negative 2 or x equals negative 3. So as our solutions for that. And then both of these solutions are extraneous, so the equation has no solution. When you graph this, you'll find that neither one of these will be a solution. So that would be a way to do it. Or you could plug it in and work it out, and you'll probably end up with trying to take a natural log of a negative value. See, negative 3, yeah, you end up trying to take a negative value here, so and that won't work. So that's why none of these solutions are true. So there are no solutions. There are no real solutions for 109. And that's your lesson today. Pre-calculus math. Email me here for questions. Thank you very much.